So how can teachers support children's 10 structure thinking? Well, at the very least, we need to know it when we see it. We need to recognize it and include those children's solution method in the classroom discourse. So ideally, we're pulling out kids' methods and talking about it. We really want to highlight when we see kids using 10 structured thinking. So here's an example of, if you don't recognize it, it seems so strange. In this problem, 8 plus 5, the two number words the child say aren't represented. They're going to say 2 and they're going to say 3. So here it goes. I needed 2 and had 3 left over. So they decompose the number 5 into a 2 and a 3 and use that 2 to get up to the anchor of 10. The answer being the 3 left over, 1, 10, 3, the answer 13. Here we see a child use it in subtraction, and again, the words the child used seem odd. They're going to use the number 2. So what does this mean? Take away 2 is 8. Well, they looked at the 14 and they took away 4 immediately to get down to the anchor of 10, but there's still 2 more to remove. So they decompose 6 into a 4 and then a 2. Child does the same thing here. I added 6 and 1 and got 7. This is a count up child. The child's going to find the count up from 4 to get 11, but doesn't do it all at one go. Just gets up to 10 with the 6 and then another 1. This child is counting up from 7 to 13, counts up 3, and then another 3, because he's able to anchor to 10. And he knows 3 and 3 are 6. So what we want kids to do here is use these methods, and it's important for us as teachers then to include it in the classroom discourse. But how do we get them to use it? Well, what we do is we provide the conceptual supports to nudge them in that direction so that they begin to use the power of these problem-solving strategies. So what are those conceptual supports? Well, if we think about our triangle, there's 3 ways we do it. In the words we use, in the marks we use, and then in the physical representation of the quantities. So we talked earlier about the number words. Highly recommending use of the Asian words, 8, 9, 10, 110, 1, 110, 2, 110, 3, etc. But we also need to think about the way we write down the numbers. I'm going to complain about that in our next module, but right here we'll just take a peek. What if we didn't write them as single digits sitting next to each other? What if we exposed their underlying value in the place value? So here, 32, it's not just a 3 and a 2, but it's a 30 on which a 2 is placed. So the use of these place value cards helps kids, it supports their understanding of place value. It's not sufficient on its own, but it's definitely not taking away from their understanding. So we are using number words, let's say 2, 10, 5, and now we're using number marks that are mirroring that structure. All right. And then how do we represent the quantity? What physical embodiments can we use to support kids thinking about 10? Well, the best one is with us at all times. All right, so we really want to support kids using fingers when they're solving problems. We can be more efficient in the way we use fingers. Here we have 2 children together solving 6 plus 8. Okay, so if one child has 6 and one child has 8, we could, of course, do a counting up, or we could look at it quickly and look for the 2 hands. Okay, full hand, full hand. So I have 10 immediately, and then I can just look at the singles. Incidentally, here I want to point out 2 different number patterns, finger patterns. This child is doing the typical US count, where we start with our pointer finger on one, and this other child over here is doing a finger pattern used by Latino children who start on the thumb, 1, 2, 3. All right. So fingers are pretty great. And of course, all that work with subitizing in 10 frames pays off here, where we can identify these and use those filled frames, the 5s and the 10s, to do our additions. So when I'm doing 8 plus 5, really I can think about, oh, I've got 2 rows filled, so that's 1, 10, and 3 left over. 1, 10, 3. Lots of new products out there. Love this one, individual paddles for kids, and their counters are magnetic. Okay, on one side there's a 10 frame, on the other side there's 2 10 frames, so we can get into some addition. Okay, and this product I've never seen before, I haven't used yet. Maybe one of you can tell us if you've used it. These wonderful dice, where the quantities on the faces are represented in 10 frames. So 10 frames are a powerful conceptual support for the quantities. Kids will be moving into using base 10 blocks to represent ones, tens, hundreds, thousands. Okay, in kindergarten, first grade, we're going to focus mostly on these longs and these singles. And after kids have lots of time to solve problems using longs and singles, we could even move to a shorthand. And this is what Fusen is telling us, is calling sticks and dots. So initially drawing out 10 dots and connecting them with a line. So this being 12, and then after students have lots of practice drawing sticks and dots, they go to an even more abstract shorthand of sticks and dots. I know that there's 10 dots on that stick. Okay, and then we see that use in classrooms. Here they're representing 22, and they're representing 35. Another physical embodiment of place value are digiblocks. Hopefully these are gaining more and more popularity in schools. I'm currently using these in a research project. I'll tell you about it in a moment, but I want you to just take a peek at how these digiblocks are used.
Let me introduce you to digiblocks. If they're new to you, they come in these Pez-like shapes that fit into this container, and the container has a lid. So if I put in 10 of the smalls, the lid fits on nicely. However, I cannot fit 11, that won't fit, and if I try to only put 9 of these things in, the lid does not stay on. Okay, so what's so nice is that this new multi-unit has the 10 smaller multi-units inside. Really important for unitizing, which we'll talk about in the next module. So kids can do a lot of practice packing up these 10s, and then we can pack those 10s into a bigger holder, and we've made another multi-unit, next larger multi-unit. So again, I'm going to emphasize that inside and not separate from are the 10 10s, and inside of each of those are 10s. So we have 100 of the little guys in this big container, and then the big moment is 10 of the hundreds fit into the next size multi-unit to make the thousands.
So again, I want teachers to know it when they see it as kind of level one, but really what I want is for teachers to support kids' thinking in the way we represent quantity. Everything's about 10. The way we count our words, 110, 1, 110, 2, and the way we write the marks.